Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming all my grade 9 elite students to lesson number 2 of module 3 Similarity. The name of the lesson is Similar Polygons, and I'm here to help you understand this topic well. So let's get started, and before that, a humble request, a kind reminder. If you've been watching my video and liking my content, then give the video a thumbs up and also subscribe to the channel. Press the bell icon so that you don't miss the upcoming videos. So let's recall from the last lesson, lesson number 1, about the concept of dilations and scale factor. For that, we are going to spend another 5 minutes on an assignment on Khan Academy. So let me take you there on dilations of scale factor and let's solve a question there. Okay, so this is one of the questions here. As you see, the triangle A prime, B prime, C prime is given to you, which is the pink triangle, big one here. It is the image of triangle ABC under a dilation. So I would want you to first observe that if the blue triangle is made into the pink triangle, it is made bigger. So this is a question on enlargement. Now, what is the scale factor? Now, because you know for enlargement, the scale factor is more than 1. So the scale factor here for the question will come out to be more than 1. So let's find the scale factor. The formula, I hope you all remember, for scale factor, which is represented by K. So I'm going to write K very shortly as the symbol to write the scale factor. So the scale factor represented by K is equal to the image divided by the original. So here the image is A prime, B prime. Any one side of the length you can take and you divide it by AB. So let's count the squares and see how much it is. So 1, 2, 3, 4, 5, 6. So on the top you have 6. And bottom you have 1, 2, 3, 3. So 6 divided by 3, that is 2. So the scale factor is 2. So we can say that the triangle has become double its size. So that's 2. Now you can also check your answer. Correct. And then you move to the next question. Let's have a look at the next question. So this pentagon A prime, B prime, C prime is the image of the pentagon ABC under a dilation with a scale factor of 5 by 2. So you have to tell what is the length of A prime, B prime. So very easy question. We will use the concept of scale factor. Scale factor is image. So that means A prime, E prime divided by its corresponding side. So that will be AE. And remember, this scale factor is given to you. How much it is in the question? 5 divided by 2. So you just need to find, let me change color here. You need to find A prime, E prime. So you can cross multiply. This is going to be multiplied with this. And your A prime, E prime would be 5 multiplied by AE. Now how much is AE? 1 and 2. You can count the square. So 5 multiplied with 2 divided by 2. Now 2 and 2 will cancel, khalas, so the length is 5 units. You can put it here and check your answer. Correct. And similarly, you can move to the next question. So I hope you understood how the dilations on scale factor has to be solved. Do the similar questions and then we'll move back to the presentation now. Now let's take some practice questions from your math book. Here you have to determine from A to B whether it is an enlargement or a dilation, and then you have to find the scale factor of the dilation. So if you look from A to B, that is from blue to green, blue to green. So from blue to green, it is definitely here for the first part an enlargement. And now you need to find the scale factor. So scale factor would be the image divided by the original, and because it is enlargement, scale factor will be more than 1. From A to B, here blue to green, it is reduction. So you know your scale factor has to be less than this. A to B, it is again reduction. So scale factor less than 1. Here from A to B it is enlargement, it is becoming bigger. So the scale factor will be more than 1. Now let's find the formula. So for scale factor it is image divided by original. So the image is this. Let's count 1, 2, 3, 4, 5, 6 divided by the original. So it is 1 and 2. So this is 3. So the scale factor is 3 here. Let's do the same thing here. Now here, even before you find scale factor, you can see that the triangle is made into half. So the scale factor is going to be half. If you see this one, it is made a double. So the scale factor will be 2. And you can also measure 1 2 here, 1 2 3 4 here, so 4 divided by 2, and similarly here. Now let's see this one. 1 and 2 length, and 1 2 3 4 5 6, so k will be 2 by 6, which is 1 by 3. Now you can check your answer. So enlargement scale factor 3, reduction scale factor half, reduction scale factor 1 by 3, and enlargement scale factor 2. So this is how you'll solve the question from the math book. Now we move on to our lesson for today, which is similar polygons, lesson number 2. And our learning objectives would be to determine whether two figures are similar and to visualize, describe, and solve problems using the perimeters of similar polygons. So first we'll do a Khan Academy exercise. It's a starter activity which is going to take 5 minutes. So let me take you to Khan Academy, identify scale factor in scale drawings, and then we'll come back to the presentation. Okay, so let's see how we can identify scale factor in scale drawing. So here two figures are given to you where B is a scaled copy of figure A. So as you can see, figure B is bigger than figure A. It's a case of enlargement. So the scale factor will be more than 1. Now let's find the side length. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 for this. So we are going to write here a little bit. Let's write. So the scale factor K is equal to the new side, the image, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 here, 9 divided by the old one. So how much is the old one? 3. So 9 divided by 3, that is 3. And yes, it is more than 1. So it's quite justified that it is going to be an enlarged one. And you so that's the correct one. Move to the next question and solve the remaining ones. Again, you see this one, figure B is a scaled copy of figure A. What is the scale factor from A to B? So very easy to see that the scale factor is becoming 4 times. 14 fours are 56, 16 fours are 64, 7 fours are 28. So the scale factor, without even doing any sort of calculation, orally we have answered this question is 4. Enlargement again. Similarly, you can do more questions. Finish this Khan Academy assignment on identifying scale factors. And that's how we are going to solve the question. So let's go back to the presentation. Now, talking about some important terms, a dilation is a type of similarity transformation. That's very true, because in a similarity transformation, you have either enlargement or reduction happening, and that's the same thing that happens in dilation. Also, similar polygons are same shape but different size, so one can be obtained from the other by a dilation or dilation with one or more rigid motions. So when two polygons are similar, their angles and sides are related. What is the relationship? So very important theorem which will form the basis of our discussion of similar polygons, that if two polygons are similar, if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So when we talk about angles, corresponding angles are going to be equal or congruent, whereas the corresponding side lengths are going to be in the same proportion. So you have reflexive, symmetric, and transitive properties. Reflexive means every triangle is similar to itself. Symmetric means if one triangle is symmetric to the other is also symmetric to the first one. And transitive, if one is similar to the other and the other is similar to another one, then the first and the third are also similar to each other. Very important similarity properties, and let's see what is their use in everyday life. So as you see here, I've already written the important information. There are two similar polygons A, C, D, F and V, Y, V, W, Y, Z in this order. The order is important. 1, 2, 3, 4. Corresponding angles are equal. So you have to find X, that is FD, and you have to find Y, which is related to ZV. So we are going to use here proportionality of sides and cross multiplication to answer the question. So let's see what can we write. So we need CD, CD is given to us, over WY. Why do we take this? Because they two are similar to each other, so the sides are going to be proportional. Both the side lengths are given, so 9 divided by 6 can be done. Okay, and DZ df is equal to x, which you don't know, and yz is equal to 10, which is given to you. So just put the values, do the cross multiplication, and here when you solve, your x comes out to be 15. You divide it by 6 on both sides. Now to find y, you need to take z V. So when you take ZV here, you take FA here. So ZV with FA, that is 12 divided by 3y minus 1 is equal to same value, 9 divided by 6, because they are given to you. So you are using the known values to find the unknown. Okay, then you do the same thing, cross product or cross multiply, and find your y as 3. Let's do another question from your math book. I will be doing 3A in this video for you. 3B is your homework. You will try yourself. So let's find X in this. X is related to the side LM. So when I'm taking that the two triangles are similar with LM, I'm going to divide with ST. So LM divided by ST is equal to the given side. Now let's go and see what side is given. JM is given. And if JM is to be taken, then with JM you will have QT, Q and T, first and third. So QT is given to you, JM is given to you. So 4 divided by 2 is equal to 6x minus 3 divided by 3. Now cross product or cross multiply, simplify, multiply, use distributive property. So 6x minus 3 is equal to 6, or 6x is equal to 9. So x is equal to 1.5. That's how you find x. Similarly, find y by taking side JL. Now we are going to apply the perimeter theorem to a scale factor and solve the question. So you are given two pentagons A, B, C, D, E and P, Q, R, S, T. If you see carefully, for these pentagons, it is given to you that they are similar. So therefore, the ratio of their sides will be proportional to the scale factor. Also, the ratio of the perimeter will be equal to the scale factor. So let's find the scale factor. If I take CD side, then according to CD, RS is going to be the proportional side. So CD divided by RS is equal to 4 divided by 3, which is the scale factor. Now if you look at the pentagon carefully, this side is equal to this side. So BC is 8, CD is equal to AE, so that is 4. QP and RS, QP and QR are equal. RS is 3 and PT is also 3. So we have to find the perimeter of each polygon. We can find the perimeter of the bigger one by adding all the sides. So AB plus BC plus CD plus DE plus AE, all of them when added gives you 30. So the perimeter of the bigger polygon ABCDE is 30. For the PQRST one, you will take it as X because you don't know. Now you divide the perimeter, which is going to be equal to the scale factor. Cross multiply, simplify, and the perimeter of the small polygon PQRST will come out to be 22.5. So very, very simple question. Try in a similar way this question as your homework. I will give you a hint. M, N, P, Q, all sides are given to you. You can add and find the perimeter. For the other one, only one side is given. You need to find the perimeter of this one also. So you will divide both perimeter and that will be equal to the scale factor. Use the fact that M, N, P, Q and X, Y, Z, W are similar. So you can easily find their scale factor. When you check your answer, scale factor will be 2. Perimeter of M and PQ will be 34 and perimeter of XYZW would be 17. So check your answer and solve it in your notebook. This is the exit sheet. I'm going to give you 5 minutes to complete. Let's start the timer and you will complete these questions and I will show you the correct answers. So the correct answer for first, second, third and fourth are these.